This is AQA A-Level Chemistry and it's the Year 12 topic, Alkenes. We're on part 4 of the Alkenes topic, and in this video we're going to be taking a look at addition polymerisation. I'm going to recommend, as always, that you pause as you're going through, try the activities for yourself, and that way you're going to know what's going well and what might need a little bit more development. So within this, we're going to look at the types of polymers that we get from alkenes, how we represent repeating units, how we draw and write out equations, etc. And we're going to start off with a very quick question here, getting you thinking about the nomenclature, the isomerism, and how you draw alkenes. So have a go at giving your answers here. And hopefully very, very straightforward. Eth is 2 carbons, so we've got 2 carbons and it's ene, so there is a double bond between them. We then fill up with the H's, so we've got 4 bonds around this carbon, 4 bonds around this carbon, and we've drawn out our ethene. And there is a particular feature of alkenes that allows them to form addition polymers, and that is the fact that we have got a double bond. So now let's have a think about how we could represent the formation of polyethylene from ethene. And we start off with our monomer, and the monomer is the alkene that we have here. And from there, we are going on to make the repeating unit of the polymer. And you can see that there is one significant change that's happened here. The double bond has become a single bond. I've still got all 4 of my H's. Now, when that bond has broken, we've still got the electrons there, and what we're doing is swinging those around because those bonds are now going to go out from the 2 carbons. Now, if I then put brackets around this, we can see that this repeating unit is bonded to another identical repeating unit on either side. And the final thing we need to do is represent the fact that there are many of these. We don't go for a specific number, we use the term N. So we have got N of the monomer forming a repeating unit, N repeating units long. With that in mind, how would you go about doing the equation for the polymerisation of chloroethene? And we've got the equation for ethene here, just as a reminder. So we start off by drawing out our chloroethene, and I've got that down here. You can see I've got N of them. And we then have our arrow going to the repeating unit, and you can see the only significant difference between the ethene equation and the chloroethene equation is we've swapped out this H for a Cl in both the monomer and the repeating unit. So let's try tetrafluoroethyne. Now, once again, we've got N moles of tetrafluoroethene, that N representing any number, and then we break the double bond, our bonds burst beyond the brackets, and we have N of these. The locations of these N's are really important, by the way. It must be left in the middle on the monomer and bottom right on the repeating unit. Have a go at propane. Now, propane does often throw up a few problems. And let's have a look. Let's draw propane out in the first instance. I've got that here. I've got 1, 2, 3 carbons. I've got my double bond. I've filled up with my H's. But when I'm dealing with polymers, I would never draw propane in that way. We're going to get rid. And we're going to put it into the same format that we've seen in all of the other examples. So I've essentially got my 1, 2, 3 carbons in a row, but where I had an H in ethene and a chloro in chloroethene, I'm putting my CH3 as one of the branching components around my double bond. So I'm always going to draw my double bond at the centre with 4 groups coming off, whatever they might be. And that then allows us to see very clearly that the only thing we're changing is the double bond becomes a single, that my bonds burst out beyond the brackets. I've got my CH3 down there. The error that people will often make is that they will have 3 carbons in a row as part of the repeating unit if they do propane, and that's what we're seeking to avoid. So do we notice anything unusual about the names of polymers when considering their structure? Well, let's take the last example we just did. We have polypropene, and you've got the repeating unit here for polypropene, and there is something very, very odd. Its name ends in "ene", but there is no double bond. Now, what we've got to remember is that the polymer name is based on the monomer that was used to build it. So we keep the "ene" because we're saying many propene molecules. Okay, that takes us to the end of this video. Thank you for listening and goodbye.